Okay, I stopped and kind of puzzled over this for a little bit, trying to figure out which way to approach first. Um, I want to come back to this part here later. I'm just going to keep checking here right now for some more. Well, let's name this. This will be the total time difference calculator. This here is obviously some local array. Defined anywhere. So we can just eliminate that one by doing a substitution for right now. And this here, well, that sure as heck to me looks like the end goal is to return a file handler, a file name, a string, I don't know. It is definitely a file thing. What does an ugly looking function like this thing do? It evaluates a simpler expression. So the question is, what does JavaScript do for evaluating strings in brackets? I can't really quite find anything online, but it's just probably my searching method. So I'm just going to wrap the expression that we're going to see what does it do. Throw it in a script, save it as an HTML file, run. So how do we get run from that? Last initial. So it looks like with the brackets, we just get rid of everything in the first expression part, which makes this more sense because now we go back to the beginning here, and this means that we get rid of this first argument, which then collapsed that into something that obviously makes sense. So we're creating a shell. So here we're actually going to be returning a Windows shell. Don't know what these parts mean yet. We're going to get to that. But this clearly here is, this is clearly a Windows shell object of some sort. Let's call it system shell. Maybe an object, maybe some other thing. But that's now making more sense. We have a system shell object that we can then process shell commands and shell expressions for. So yeah, this part is a function. This is telling it to give us the full qualified name for this temp variable so that it will have a executable file name in the temporary folder. Do we have any other ugly looking variable names here yet? Well, this is an argument. No idea what argument type is yet, but clearly a W script shell, a command, a window style, meaning hidden, wait on return, boolean, just finished. So in other words, it's going to run a command, whatever we provide it, on a hidden window that disappears immediately whether there are errors or not. So, okay. This code we no longer need anymore. This was just the way of it looping through until it was finally meeting a condition where it could go ahead. Where do we call this function? We don't use that function anywhere. So that is simply garbage code thrown in to complicate the matter. So if we simplify this, and that this calculating the time differences was simply an elaborate way of we no longer need that code. So this becomes much more simplified with this single screen. So this still is some function that does something, and I don't know about this structure form for assigning a variable to a function this way. It's a function that takes no argument, but I don't know what this component means. Does it impact it? That doesn't even mean anything. It's an assignment for a variable that doesn't get used. Might have got used in some of that crap stuff, but I don't think it did. It looks like it's doing something with 3 arguments of some. Clearly, whatever is going on here is this is definitely making a reference to an object, a WScript shell object. And we don't need these anymore to tell us if we were going to be running or not. So we're just looking at the malicious code itself, or the code behind what would happen if the code ran. This is the code that it would run. So all that 20-something thousand lines reduced to here. Effectively, what this is saying is an interpretation. Is this going to be a path string, or the object? More likely going to be a string. Save to file will be string. 2 is probably the mode. We don't even need this B part here right. Open, that's a method with 3 things in it. Anyways, what this is first doing here is this is opening a web object. It is providing the address to open. It is sending the command. It is sleeping for 163 milliseconds to wait for a response. Effectively, remember, this is all within a loop of waiting for responses before we continue. So we resume with a continuation. What we do now is we make 2 new file stream objects. We open them. The type, we could probably look, and that will tell us whether it's binary or string. We take the response body, return value, content of that web page, and write it to the stream. Now this streamer A looks to be just a, this could be just a red herring, because remember, this is equivalent to, this may not even do anything. It may not do anything, or these may refer to the exact same object interchangeably, in which case this could be the same as setting the position for B, and this could be closing B. Either way, it looks like what it's doing is it is getting the value from the web page and writing it to a file. Then closing, and then it is opening a shell running the command argument for that file name. So it is basically saving an executable file by writing the downloaded result into an executable file name and then running it. So this is, in fact, actually downloading a virus from another site. And this is how it would run. Now again, it's probably the code that it's going to actually run is just opening up crap advertising and stuff like that. But it could very well be viruses. But that's how they get around the detection. You're not actually being emailed the virus. You are being emailed the instructions to download the virus. But you're not even downloading a virus. You are downloading the data that is written into a file that upon being written becomes the virus. There. So I feel pretty good about that evaluation. I would just like to figure out some of these notations to clean up these parts a little bit. I think that this has something to do with when they're written in this form, they become processed first in line before the rest of the first line of code is executed. And as a result, that ends up from here actually creating the WScript object that then gets referred to. So it's kind of a circular thing, I think, but something more to look into anyways. And again, this is all just exactly what I've outlined. I'm curious to actually run it and see what happens, run it in a protected environment, but chances are that that file may not even be there anymore. Let's just actually see if it is. It'll just return noise because it's not actually data that is executable. I'm guessing that means page cannot be found. So this was a site clearly that was hijacked, had some junk stuck on it, and they cleaned it up, and the script is no longer even going to download a virus because it's been cleaned off. Earlier this year, my web server was taken over by hijackers, web hijackers, via infecting the WordPress installation that I had on my system. In this particular case, I actually did a very thorough forensics job to find out what had actually happened, just for self-satisfaction. What I was observing was that a web browser would open the web page that had this code injection in the WordPress headers for an obfuscated JavaScript that encoded a function that simply added the line to link to another JavaScript file in the web browser object. That new script from a foreign site would be downloaded into the same web page and processed, and the end result was that that JavaScript file actually did nothing. Or it did absolutely everything, depending on your point of view, and I'll clarify that as I show you what this particular script that downloaded was doing after being obfuscated. This was the script file downloaded. So again, as you see, one nice long single line, several thousand characters. There are some nice tools to help break them up a little bit, but even so, you can still see that there's very little code in here and one gigantic long string. If I word wrap this, you can see it a little bit better. This doesn't really tell much. There is a lot of gobbledygook here, what's called packed JavaScript. In fact, they even make fun of you by making the function called packed right there. So as a result, it's a function that takes part of itself as the input to produce the new output result as the function that it wants. It's a series of bit shifting and adding offset character codes and combining with some mathematical functions and doing some regular expressions. There's a massive amount of code from right here. This is what the code becomes after it has de-packed itself into a new code. So what this JavaScript is actually doing is it was pulling back what the document refer was. The document refer is the last website that you came from that directed you to the site you're viewing. Then what it does is it looks through that referral link at all of these possible keywords. So if your referrer was a search engine, then it creates this list of names, 53 possible entries in an array, and then it picks one of those at random. 52 out of 53 being this other website, the chances of getting this back, or actual web page that you're looking at, is quite low. In fact, it will randomly pick the other website. And what it then does is it changes the actual web page address that you're viewing to be that new website, which would be an advertisement for whatever. I'm sure that this script was probably used to show that they could put 20 or 30 different companies in here and random like other things, but I thought it was very interesting because of the fact that it did nothing or it did everything. Only if you came in from a search engine to my website would you encounter this garbage and get redirected. But every time I went to my website through my own links and through my shortcuts, I never saw anything other than the final end result pages I was supposed to. And that's how they manage to hijack web servers, is because the web owner is not aware. Packed JavaScript. You can imagine the code earlier put through a packing system. We would have this garbage